Let's recap where we are and what we want to do in today's video. So in the last video, or maybe not in the last video, but in recent development work, I worked on some of these things. Consider getting rid of the slug. We can move this down. This is not a high priority. We'll put this down below maybe. When sending a diff or present state, there's no initial position, so I worked on this, so we are getting the initial position now. We need to add back teleportation. This is kind of the work that I did over the last few days. Restore audio WebRTC. To create the UI, I consider using React, but then settled on Svelte. And so one of the things we could add back later is add video, camera, and screen sharing. And let's see what else. We wanted to add a cylinder type to one of the things you can create. I think, let's try to do this. Let's try to port our iframe menu system to Svelte, because that I think will open the door to all kinds of UI menus that we can do there. So I was refactoring, and so let's kind of go through the code base again from the page loading. We're going to hit a controller for the space. So the main entry point when you're loading a page goes through this space controller. Space controller is going to find the space by the slug, looks for the struct that comes from the database, and if it exists, if it doesn't exist, it will say there's no recognized slug here. Otherwise, it will nudge the space, which is to start the gen server if it doesn't exist. And then it will render this. So starting the gen server just starts that up. And why do we need the gen server? So we have a space server. What is this for? It is the home for our ETS table. So when this thing is created, start link with an OK and a slug, and that is handled down here. OK and a slug. We create a new ETS table that is owned by this place, and so when the gen server is garbage collected, so will all the data in the ETS table. So this is member movements. It's a set. Any other process can write to it, read and write to it concurrently, and it has and we return a reference to it. From there on out, whenever we connect to a space channel, we get a reference to it. So after join, we go into the after join handler, which is here. We'll get our initial position. Then we get a reference, and if the reference exists, then we'll insert into that this tuple, which is the member and all of the position and rotation. Notice we don't include the left and right hand, so we haven't done much VR stuff, so that's something that we could do. Add back teleportation. So under here, we could track left and right hand controllers. We could move the immersive button from right hand corner into the menu area if we wanted to. And we definitely need to keep track of teleportable floors, add pickup and throwable objects. These are things to work on. Going back, so we have the show template. So we're rendering the iframe business for the existing menu over here. We have a space canvas, which is the destination of what we're loading up. So this just spits this out into the page, and then we add a bit of data that we are passing from the back end to the front end, which is the serialized space and some member ID user token, which allows us to connect to the sockets. So once this is here, Orchestrator kicks in. And why does it kick in? Because we have this XR root, which is the layout, and this thing includes this script tag, which is orchestrator.js, and that is compiled for us using our pipeline, which is our ES build script, produces this artifact, two artifacts actually, app.js, which is all the other pages apart from entering a space, and orchestrator.js, specifically bundled for and only included by the XR root, which is the layout that's only included in our immersive experience. And orchestrator.js entry point, let me close some files. Let me just make sure that I'm recording. Yes. Orchestrator TS TypeScript is compiled into orchestrator.js by our pipeline, and it will spit that out in the priv directory under static assets. So here it is. Not too big. I think it's maybe how large is it now? About 5,000 or so lines. All right. Okay, what does Orchestrator do? So under assets, under JavaScript, Orchestrator sort of ties everything together and is a definition of a class. So we have this class, and it's instantiated at the bottom. So when the DOM is fully loaded, and that's important because we're still rendering the page, so we don't want, because this is included at the top, we don't want it to start kicking on and not be able to find some of these variables. So we wait for the DOM to be fully loaded, which is not too much of an issue. There's not much there, except for this whole serialized space thing. And then we grab a couple variables, and then we instantiate a new orchestrator and inject it with a couple of things. So we have the space canvas, which is the ID of the canvas, the member ID, which we put on the page, the serialized space, which is the serialization of the space, and a signal hub, which is created here from a separate file, which creates an instance of a subject of signal event, which is an event of a string and a payload of any. And this is just some event that we can send messages from other pieces of JavaScript from one class to another without actually including these classes in each other. Because maybe if you have to send messages back and forth between two classes, you can use a third-party broker like the Signal Hub in order to send messages and listen between them without one class actually including the other class and so forth. So we have the Signal Hub, and we refactored this a bit. So this orchestrator sets up the socket in the channel. It includes the RTC client, the web RTC client. includes Signal Hub, a scene manager to manage all the Babylon.js stuff. It includes a couple of types. So we move this to another file. We don't need this. Okay, so we define orchestrator as a bunch of this stuff. Let's see. Some of it may not be relevant. So let's see. Okay, so we get past Signal Hub. We get past the ID, the public member ID, and it's kind of the one and only entry point. The one and only entry point into creating everything that we need JavaScript wise. So it'll set up the socket. What does it use the slug for? Okay, it uses it to set up, sure, the space. What else? Okay, I think that's okay. So it passes it to the Agora client is the name of the channel. Okay. Sets up the WebRTC client. This was just a note. We don't need this here. Sets up the... Okay, so this is just setting up the default behavior of what you want to do here. Okay. Default audio playback behavior. It sets up a scene manager, which takes a Signal Hub, but then scene manager needs a channel. So the question is, I mean, does it need a channel, or can we just listen to the Signal Hub? That's something I've been debating. Anyway, so we listen to some message. So if the orchestrator... Oh, okay, so this is something that I was sending all kinds of messages to Signal Hub. I'm just passing it through there. So Signal Hub gets a copy of everything. And if we get a message like server lost, then we'll just redirect to the home page. And who generates this message? Server lost. It happens when, oh, you don't have a... for example, you left the browser open, but the gen server closed. When it tries to reconnect, we'll get something like this, like an error. And we just push this to the message to the front end, so we stop retrying multiple times. Then for debugging purposes, we put this on the window, and then we start Svelte land. We pass some of these things in. We got a WebRTC client and a Canvas ID. Okay, we have a join space function to join the space channel, which is only invoked after some things happen. Let's see. Yeah, so we say start, and then we only call join the space when we receive a message on Signal Hub that said join the space, which is useful, or we could just move this functionality someplace else. But I guess this is fine for now. Okay, then we create the scene. We start the scene engine to start rendering, start the render loop. And listen for messages. So this is started immediately here. Okay, so then it has a couple of neighboring utilities now. So Scene Manager is our newest addition, and it brings in all the Babylon stuff and everything responsible for drawing stuff. Signal hubs, not doing anything. Types are just types. We've got this Agora thing, which is instantiated in the orchestrator, and you can send it messages to talk to the Agora service. And this is just an interface. One of the things in the Scene Manager that's being used is accessing the session storage, but it's not the only one to access the session storage. I believe in Svelte world we're also doing things with session storage. Okay. So because these APIs are similar, I'm thinking maybe we can move them someplace here. So here's the session storage set item, and then we're also using session storage get item. So we could call something like session persistence. I don't think we need to do anything in the constructor. We can have a couple of known keys. What are things we do? We get like get camera position rotation, and then we can also save the camera position rotation, and we can get microphone settings, get mic and output choice, and save mic and output choice. Then we could have a couple of constants in here. So in here we had this session key. Let's take this out of here. Put that here. And export const session key for the mic options is mic. Call that whatever you want. So in the, let's see, app, under here, mic setting string, if it's not setting string, So we'll just do this. So here you're checking if the session key mic options. Can't find name. Oh, sesh key. We're looking for that. And if it's nothing, so so maybe we need a method just for this. So get and parse key. You give it a key, and then it will grab the key. If key, then let's just say JSON parse the key. Return this, else return no. And you can have save value at, or just save. Give me the key, and give me the value, and we'll do no session storage dot set item. Give me the key, and then give me JSON stringify value. Then these are just really return get and parse key with session on camera business. Likewise with the mic stuff, this will be mic options. And then for saving, you got to give us the new data, and then you will just this save session camera with the data, and likewise we'll get this save with session mic options and the data. So we've extracted this into session persistence. And we can import this into the apps spelt, import session persistence from session persistence. And so the mic settings equal we don't need to create our own, so maybe we can just say session persistence like this. In session persistence, we'll just create a new class, so export const session persistence equals new session persistence. So then we just include session persistence there, and here mic settings string. We don't need to test if it's, so it can just be session persistence, and we want to see if the mic get mic output choice. We'll call it mic choice. Okay. So if the mic choice is null, return there. Otherwise, mic settings string. Okay, that's the mic choice. Okay, mic choice. Let's just call this mic choice. So we could be more helpful by returning types here. So here, where did it get this from? This comes from here, and where are we saving it? We're saving it over in session storage here. So we're saying it has this, and they're both strings. So over in the session persistence, so if we go to data, we can say that saving this returns this, which is a string, and this is a string, and when you get this back, you're also getting this back. So get like an output choice returns this or no. And so over here, we can replace this with session persistence, and we'll save this business. And it knows what key to save it to. Okay, so I think we're covered on the mic end. And if we go to the camera end, so in Scene Manager, we also can import business from here. So we'll import session persistence. And we'll just use it in any place we're doing something with session storage. So here we're getting something. Okay, so we can say session persistence. Let's get the camera position and rotation. And let's say this is cam position and rotation. But if not cam position rotation, if there's nothing in there, then we'll find the spawn point and then we'll set the spawn point. Yeah, I see a problem here, which is we're not storing the rotation. Or are we? What does this thing do? Find spawn point really quick. I want to see. Okay, it does give you the rotation. All right, never mind. Go back. Where were we? Sorry. Okay. So we'll use session persistence, save the camera position rotation, which will be the spawn point. And that replaces this line here. You return the spawn point. If it's not empty, then we can just return it. We don't need to parse this because it is already an object. So we get cam, position, and rotation. So save my position rotation. Is that used anywhere? Save my pause rot. Okay, I don't think it's used in this file. Save my pause. Okay, so it was used in the orchestrator out here, and this becomes, oh, when you wanted to forward this message and then kind of cache it. So we can actually just bring in this session persistence in here as well. Session persistence there, and then replace this because we've extracted this out of scene manager. And we can, does it have to be passed in, or does it know? Can I just do that? Save camera position rotation with message payload. So I just used it as a kind of available variable. It isn't passed into the constructor. I'm not passing it in here. Let's test it out. Does that work? So let's go to a local host over here. Open up the console here. Okay, we get some error here. Unexpected token C, get and parse key. If when the session starts, if key get and parse key. So what was the error? Unexpected token C in JSON at position 1. Alright, get and parse key. Let's add some logging. Okay, let's do this. Try catch error. Console.log tried to JSON parse this value, and it was oh, gotta get, okay, this is wrong. Value is what goes back. So if there's a value, then parse that value. It says save key. Okay, key is a string, value is an object. Let's clear this and try again. So join the space, make a selection. I'll choose communications, confirm. I'll now move us to this very corner so I can just see this, and I'll turn us a little bit. Now I'll refresh the page. So refreshing, that angle is preserved and communications is preserved. So the session is working. I'll refresh here. And looks like we're good. So it's a good place to stop. We did a refactor of pulling the session persistence out into its own class.